Dear viewers, greetings. Today we can discuss about polysaccharide cellulose. Cellulose is not only the most abundant extracellular structural polysaccharide of plant world, but is also undoubtedly the most abundant of all biomolecules in the biosphere. It is present in land planets, but it is completely lacking in food items like meat, egg, fish, and also milk. It was first noted as such in 1838 by Anselm Payen. It occurs in almost pure form in cotton fiber at 98% in combination with lignin and also hemicellulose. Like starch, cellulose is polymers of beta D glucose. Next, sources or occurrence of cellulose. Cellulose is present in all the photosynthetic organisms like plants. Can be found in many microorganisms like fungi, bacteria, and algae. Cellulose may be used as one of the structural cell wall polysaccharide of green algae. It is also found in small quantities in brown algae, Rheophyta, most of the red algae, Rhodophyta, and most of the golden algae, Chrysophyta. In some fungi, cellulose forms as an inner cell wall layer. Next, move on to properties of cellulose, which appears and also it is fibrous, touch white solid, has no taste, is odorless, fiber-like substances. Composition of cellulose is polymers of beta-D glucose. Molecular formula. The basic chemical formula of cellulose molecule is C6H10O5N. Molecular weight. The molecular weight of cellulose ranges between 2 lakhs to 20 lakhs, thus corresponding to 1200 units to 12,500 glucose residues per molecule of cellulose. Next, solubility. It is insoluble in water but soluble in ammonical cupric hydroxide solution, that is called as Switch's reagent. Reaction with iodine, it gives no color with iodine. Next, hydrolysis. Cellulose is a relatively inert material. Inert means inactive material and is completely degraded only under the most drastic condition. For example, it may be hydrolyzed to glucose when treated with concentrated H2SO4, sulfuric acid, or HCl, hydrochloric acid, or concentrated NaOH, sodium hydroxide. Next one, enzymatic hydrolysis. Under the enzymatic hydrolysis, we are using the cellulase as a enzyme. In man, the cellulose is not digested since it does not possess an enzyme capable of catalyzing the cleavage of beta glycosidic bonds. Hence, it serves an important source of bulk in the diet. However, the ruminant example cattle, sheep, goat, camel, and giraffe. These are called as ruminant animals. And certain wood eating insects are because the microorganisms present in their digestive tract do possess such digesting enzyme. Digesting enzyme means these are having the cellulase enzyme. Next, move on to structure of cellulose. Cellulose C6H10O5 enzymes is a long chain polysaccharide carbohydrate of beta glucose molecules. It is formed by beta 1,4 glycosidic linkages. It forms the primary structural component of plants. Beta 1,4 linkages make all the differences. Strands of cellulose form extended ribbon-like structure. Interchain hydrogen bond allows multi-chain interactions to form cable-like structure. Polymers with alpha glucose or helical polymers with beta glucose or straight chain. Parallel cellulose molecules held together this way are grouped into microfibrils which form strong building materials for plants. This is the structure of cellulose. The glucose molecule, first carbon atom and also fourth carbon atom linked together to form the cellulose. Here beta glycosidic linkages occur. Next, applications or functions of cellulose. First, paper industry. Cellulose is mainly used to produce paperboard and paper production. Smaller quantities are converted into wide variety of derivative products such as cellophane and also rayon. Next, biofuels. Conversion of cellulose from energy crops into biofuel such as cellulosic ethanol is under investigation as an alternative fuel source. Cellulose for industrial use is mainly obtained from wood pulp and also cotton. Next, dietary fibers. Some animals, particularly ruminants and primates, can digest cellulose with the help of symbiotic microorganisms that live in their guts, such as trichonympha. Human can digest cellulose to some extent, but it mainly acts as a hydrophilic bulking agent for fish and is often referred to as a dietary fiber. Next, medical applications which used as dressing material or tableting cellulose derivatives. Here, hydroxyl group replaced cellulose acetate. Acetate replaces approximately 2.3 to 3 hydroxyl group per molecule. 25% of cellulose acetate, 75% cellulose ethanate combination used for tablet coating. It is used in making packaging materials, toys, tools, etc. It is the cheapest raw material produced. Next, methyl cellulose. Product produces viscous suspensions, good emulsifier, and vegetable mineral oils, barrier creams, bulk laxative, tablet binder. Oxidized cellulose, which used for 20% hydroxyl groups converted using HNO2 acid, nitric acid, hemostatic properties, and gas lining dressing in lint. Cellulose nitrate, nitration of polymer, gun cotton, cellulose nitrate. This was first successful plastic. It is used in making toilet pieces and also industrial items. Next one, ethyl cellulose. This is produced by treating alkali cellulose with ethyl, either ethyl chloride or ethyl sulfate. It is used in flashlight cases and electrical appliances parts. It is the lightest, most expensive of the cellulose sticks. Thank you. Thank you, viewers. Thank you for your support.